Statistics is all about managing data, and that can be broken into two different divisions. The first of which we'll study is called descriptive statistics. That's finding a way to summarize the data for our audience who might not see the entire list of data, or perhaps the list of data is pages and pages long, containing thousands of numbers. Trying to describe the data in a nice, concise way is very effective in communicating our understanding of the data and trying to convince people of a certain opinion that we might have about the data. The second division of statistics is called inferential statistics. It's involving making predictions and estimations from the sample so that we can actually understand the population better. But we'll begin with descriptive statistics. It's something that you're actually quite familiar with from school and real life already. In this video, you'll be looking at, first of all, answering this question: what are the key ingredients for giving a complete description of data? So how do we summarize the data the best? And also in this video, you'll be looking at maybe refamiliarizing yourself with what a stem and leaf graph is, which will be the first graph that we study in the course this fall. All right, let's get into what goes into making a complete description. I like to call these the Fantastic Four, which I borrowed from the Marvel comics. And the Fantastic Four for describing data, to give a fantastic description, would be to provide a center, a spread, the shape, and number 4 would be any gaps or outliers or anything strange with the data. So let's begin by looking at a center statistic for the data description. So when it comes to providing a center, you've got some choices. You could use the average or the mean. You could use the median, the mode, or even something that's maybe you're less common with, called the mid-range, which is the average of the lowest and the highest numbers. So in giving one of those numbers or one of those statistics to our audience, they get an impression of what the center of the data might be. Now, it's important that when you're giving this description, do not use a sentence such as, the center grade for the course was a 75%. That could mean many different things if you're going to use that sentence. So you never want to refer to these as the center. You just want to be specific. So it's far better to say something like, the mean grade was a 75, or the median grade was an 82. So be specific when you're talking about which center you're using. Do not use the phrase, the center is, and then give a number. So how do you decide which center to use in your description? Well, it comes down to what you're trying to actually do. So what is the purpose of your description? You might be just trying to communicate the information accurately to an audience. In that case, you may want to give them as many pieces of information that you have, besides handing them the data set or giving them a file to look up. You want to give them maybe the mean and the median, or give them all 4 of them from the last slide. But you don't want to overwhelm your audience either. So that's the bottom section here. Why choose it all? Why not give them all the information? Depending on your audience, you might be overwhelming them with too much information, and that's one reason why you'd want to maybe select 1 or 2 of the centers to describe. Another reason why we would want to choose one center over the other would be if we're trying to convince someone or represent the data more accurately. So perhaps let's say that there was a test which 10 students took and 1 student didn't show up for the test, and on the file for the school, it actually says the student earned a 0 for not showing up. Now the class average would be really suffering because of that 0. So giving a measure of center of the average would be a poor choice, because that average would have been torn down quite a bit by that 0, which disrupted the impression of the entire course. So it's all about making some smart selections that way. All right. The second of the Fantastic Four would be to give a spread for the data. And just like the centers, you have certain options here. You can give the range, which is the maximum minus the minimum. And that's the easiest spread probably to give. There's something called the standard deviation, which you may be a little bit familiar with, but I think most students at this point aren't really super familiar with what standard deviation is. And of course, it's going to be a major topic in the course. Very briefly, the standard deviation represents a typical distance from the mean. And, like I said, there'll be many more lessons built into understanding what standard deviation is all about. You could also provide for a measure of spread, the IQR, also known as the interquartile range. We'll be talking about that later in this unit. And even also a fourth option would be to give the variance, which is the square of the standard deviation. So it's going to take a little while to get into that. But there are options there as well for, just as the spread, just as the center, there's options there for describing the spread of the data. The shape of the data, if you can't see a picture of the graph, if you can't see a graph of the data, it's good to just give a visual, instead of giving a visual evidence, you could describe the data as being symmetric. You could describe it being concentrated or stretched in a particular way. And like I said, the graphs can actually help out quite a bit when it comes to describing the data. And this is only the first day of it, so we'll be talking about we'll be using the word symmetric if the graph is pretty even, or the data is pretty evenly distributed. And if it's concentrated towards the lower numbers, we'll say that it's stretched or skewed to the right. And if the data is concentrated towards the higher numbers and stretched to the left, we'll be referring to that as the data being skewed to the left. And then I left the thing here to represent the strange things that we might see in the data. He's one of the stranger characters. He's made up of rock in the Fantastic Four comics. And the fourth and the strangest things to mention about the data are very important. Are there gaps in the data? Did no one score in the 70s on a particular test? That'd be a bit strange if kids just got 60s and 80s and 90s, but there's an entire gap, where no one scored any. There were no test scores there. It could be pretty telling when it comes to a group of students. And then of course, are there any outliers? And an outlier would just be a number that just doesn't fit in with the rest of the data. So a number that's so extremely small or so extremely high, where it's going to be pulling the average in that direction. And those are certainly something that you'd want to call out if you see in the data. So besides the Fantastic Four, to describe the data, we can look at graphical descriptions, and that's what we'll be spending some time with this unit. We'll begin by studying stem and leaf plots, sometimes just called stem plots. We may be discussing dot plots, which are very simple graphs. Definitely box plots, also nicknamed box and whisker graphs. There's histograms we'll be studying as well, and you may come across in this course segmented bar graphs, pie charts, or even some other graphs that aren't even listed here. But this is just the beginning, and we're going to talk about the most popular graphing tools available for us. And we'll start with the stem and leaf graph. So a stem and leaf plot has some advantages. It lists all the data in the plot, so you can see some specific details about the data, and it organizes the data from the lowest. Well, it says from high to low or from low to high, and it also organizes it by intervals, like the teens, the 20s, the 30s, the 40s, or the 100s, the 200s, the 300s, and the 400s. When it comes to organizing the data, it's listed in order and in different categories. And all the data is included, as I mentioned. And from the stem and leaf graph, you can get an impression of what the shape is. And the greatest thing about it is it's very simple to create and understand. So here's an example. Given the list of numbers here, they're arranged from lowest to highest for convenience. We can take those numbers and decide, well, the lowest is in the 20s, the highest is in the 90s. So our stems, or our main categories of the data, could be from the 20s, 30s, 40s, 50s, 60s, 70s, 80s, and 90s. So you can see that the stem is listed here in this first column, showing the 20s all the way to the 90s. And the leaves, or the leaves, the maple leaves, are just the ending of each of those 20s. So we've got the first one as being 22, so 22, 25 is the next one, 26, and so on. When it comes to generating these by hand, they're very quick to do, especially if the list is in order. What you want to make sure you do when you're actually doing this is by hand is to actually space them out appropriately too. So you can see that this row of numbers here is just as equally spread out as these numbers in each of the rows that show up beneath them. So you don't want to take this list right here, so let's say in the 40s, and kind of cram that space all the way in. You want to give each new number the same amount of space as you did above. And the purpose of doing that is so that you can then accurately describe what's happening with the data. And you could rotate the stem and leaf graph as I did here, and imagine that as being just a very quick bar graph of the data. And now that we have a picture of the data too, we can actually describe the shape of it. Well, we could actually do the Fantastic Four. We could do what is a center, what is the spread, what is the shape, and are there any interesting features or strange things about the data. So we'll get a closer look at that when I click on this. But so very quickly, looking at the graph, since it's going to disappear, the way it's tilted here or rotated to the left, you can see that there's a concentration of the numbers here in the 40s, and the graph is actually stretched towards the right because there's only a 99 and an 87, those two higher scores there. So you would say that this is skewed to the right for its shape. Well, let me just click on that link. All right, so this is bringing me to a website where I actually got this information from. And what's nice about this is it's online and it's a very quick way to actually create a stem and leaf graph. So the data was already entered into the computer, and once calculate was hit, it actually gave a lot of the statistics and a lot of important facts about the stem and leaf graph below. So the range in the data would be a measure of the spread. So it went from 22 to 99. So 99 minus 22 is 77. I didn't need the internet to figure that out, but it's for our convenience that it's already figured out. They're telling us that the average is 51.52 and that the median is 48. We're going to talk a little bit about that. So in this particular case, they're giving many statistics here, maybe more than you would need to know. And one thing that's not been calculated yet is, are there any outliers in the data? So from here, that's something we'll have to calculate, but just from my eye right here, it doesn't look like any of the grades are particularly strange. I mean, if these are test grades, I mean, it's pretty awful that some students got in the 20s and only one student got a 99. But, I think it would actually take quite a bit to actually um, get an outlier with the way this data um, is right here. So let's finish off the video with just this. I'm not writing it down, but so when it comes to describing the list of data, the list of numbers right here, the data, I would easily provide myself with a stem and leaf graph, and after that I would dig into that Fantastic Four and maybe simply say that the average was a 51.52, that the range was 77, that it is skewed to the right, and there aren't any gaps in data and probably not any outliers either. Again, I don't know that for sure about the outliers, but that'll be something that you'll learn soon this unit in terms of how to actually calculate if there are strange scores in our data set. The last thing to mention is how the mean and median is telling us some information about the shape of the graph. Now, most often you can apply this idea to statistical graphs. So in this case, the average is higher than the median. The average is non-resistant. The average, or the mean, will always get pulled, kind of like gravity, towards the skew of the graph. So in this case here, the average is higher than the median. The median is resistant. The median pretty much won't budge. It is not heavily influenced, or it's not influenced at all by the extremes and the highs, the extreme highs or extreme lows in the data. So the median is the score that's in the middle of the entire pack of numbers that are there. Since the average is higher, from that alone, you can probably assume that it's skewed to the right, which is something that we mentioned before. If those two numbers were identical to each other, we could say that the graph is, or the data is, symmetric. And if the mean was much lower, let's say that there was a student that got a 0 on the test, then the mean certainly would be much lower than the median. And you could say that without even looking at the graph, that the graph is skewed to the left. All right, so that is a quick walkthrough of describing data, and this is me working from my home in August, so I was getting a little jump on the school year here. So I'm going to go up and enjoy a summer day instead of being here in my basement. You guys have a great day.